Welcome back to Notre Dame Day. I'm Emily Evans, and I'm joined in the studio now by Professor Kevin Bowyer from the College of Engineering. Dr. Bowyer is the Chamel Prine Professor of Computer Science and Engineering and also the Chair of the Department of Computer Science and Engineering. Dr. Bowyer, welcome to Notre Dame Day.
Thank you very much.
We're excited to have you. Can you please tell us a little bit about where you're from and how you got here to Notre Dame?
Well, I came to the University of Notre Dame in 2001. I left the University of South Florida to come to South Bend, Indiana. You may challenge my geographical perceptions of the country because they both have south in them. But 14 years later, I'm still the department chair. And my younger son, is now a junior here at Notre Dame.
That's exciting. I understand your department has a strong focus on computing cost-effective healthcare. Can you explain to our viewers what that means?
Well, as a department of faculty, we were looking for a theme that was big, that in the sense of connecting with a lot of the faculty in the department, and the sense that it was big and connected with something important in society. And if you think about it, the cost of healthcare, whether you think of it at the national level, at the state level, at the level of a small company, a large corporation, or individual family budget, it's one of the fastest growing and most unpredictable costs there is. So we thought the theme of computing cost-effective healthcare would connect as something needed with everyone. And it also cuts across different areas of our department. So for one example, Professor Danny Chen, who is an algorithms and theory computer science person, has been looking at how to compute the prescription to deliver radiation therapy to a tumor in a person's body. Dr. Chen's group was able to come up with algorithms which would accomplish this in about 40% less time. So if you're a patient laying on the gantry, the time you have to lay there for the radiation to be applied to the tumor to achieve a certain dose is reduced by 40%. This means that big expensive machine can treat more people per unit of time, which is reducing cost, but it also means you have to be still a shorter period of time. So the chances of the dose being misapplied and not hitting the tumor tissue but hitting normal tissue is reduced, and so it's higher quality healthcare. So that's the kind of thing the story we'd like to be able to tell. By applying computing technology, you can reduce the cost and make it better at the same time. Though to be honest, we'd be happy with making it better at the same cost, or reducing the cost and keeping it the same. But that's the sort of idea. Professor Laurel Rick in my department is looking at robotics and simulation of android robotics, that is ones that have facial expressions to help train healthcare professionals. Professor Patrick Flynn in my department has been looking at test strip technology to test medicines for whether or not they're counterfeit. In the third world, a lot of the medicine that's sold for malaria medicine, for example, is counterfeit. It would be nice to be able to detect it in the field. And another one we could talk about later, Professor Chris Polabauer, along with Patrick Flynn, has been working on concussion detection technology.
Okay, and you yourself are an expert in biometrics and facial recognition. Could you expand a little bit on that and tell us about some cool research projects that you've worked on in that area?
Well, I've been working in biometrics since 2001. It was a little bit of a surprise to me. I had imagined I would be doing more industrial robotics or medical imaging sorts of technology, but you remember the fall of 2001 was 9/11. And that rerouted the research careers of a number of people, myself included. And so we've been working in face recognition, analysis of tracking and analysis of people in video and in iris recognition for the last 14 years. Some of the fun recent things we've done in iris recognition, the iris is the part of your eye around the hole that sort of adjusts the size of the hole to let light in. You can use the pattern of texture there to identify the person, to produce a code that would be a unique code. In fact, your left and your right eye each have a unique code in the iris texture that could be used to map to you. Well, if you have dark eyes like I do, and if I wanted blue eyes for some reason, and I bought special contact lenses, I could make my eyes look blue, but I would also put that pattern over top of my natural iris texture. So if you were looking for me crossing the border, all of a sudden I wouldn't match to me. So my group has come up with a state-of-the-art algorithm for finding out from a picture of the eye whether or not it's wearing a cosmetic contact lens, a colored contact lens. That's one example where we're leading the research groups all around the world. Another is in tracking the effects of aging and how it impacts iris recognition. So in there, we're correcting some of the errors, or writing papers correcting some of the errors in a National Institute of Standards report on this topic.
Okay, and another group in your department won the First Source Commercialization Award for their efforts in concussion detection, and they're also working with GE and the NFL. Can you tell us a little bit about how computer scientists can help with detecting concussions?
Yeah, it probably sounds unusual to imagine that the National Football League would be supporting research in the computer science and engineering department. They don't necessarily seem like they have a lot to do with each other. We do have one scholarship football player in our department. It's the first one in about 10 years, but we do have one. The problem of concussion detection has become one of the widely talked about problems in our society, whether it's girls soccer, whether it's men's collegiate football, whether it's IED devices for our servicemen and women in serving in other countries. The problem of detecting whether or not someone's had a concussion is of huge importance. If you send a soldier back out into the field when they've got a concussion and they aren't thinking right, it could be deadly, literally deadly in the very short run to them. If you send football players back onto the field repeatedly with concussions, it could be debilitating later in their life. So Professor Bowyer and Flynn and their group have developed a technology that can be hosted simply. So on an iPad or something like that, you can have this program and algorithms. If the player interacts with the iPad, uses the application before the event, and then again after the event, or if they get a big hit and the coach calls them over and says, go through the thing again, it compares their speech pattern from before, the normal, and afterwards, the maybe not normal, to come up with clues to tell whether or not the person has suffered a concussion. So it's great because it's inexpensive. It can be hosted on a mobile device. It's reliable. It's consistent. It's not going to be influenced by, that's the star running back, and he really wants back in the game. It's not going to get carried away with emotion and maybe make a mistake and make an error the wrong way and let the person back in. So we think this is a great example of technology that everybody can identify with and that is cost effective.
All right, Dr. Bowyer, thank you so much for joining us today.
Thank you for having me.